All right, we're back. We're looking at the second problem type, and I'm actually asked two different questions on this problem here. But in this case, we have an object, and we're still looking for the height of the building we're standing on. And we have the object, but instead of just dropping it for free fall, we're going to throw it upwards with an initial velocity of 12 meters per second. And we time it, and it goes up, peaks, comes back down, hits the ground at 6.5 seconds. And I'm asking how tall the building is. Well, we're going to look at a couple different things before we actually get that distance. First off, we focus on this point up here, the peak of the motion of that object. If I ask you what the velocity is there, a lot of people would say the velocity is 0, and that's true. At this point right here, velocity is 0. But if I ask for the acceleration of the object at that point, a lot of people also say 0, but that's not true. Acceleration is a change in velocity, so you don't want to just consider one particular velocity. And if you think about it, right before this point, and as well as right after that point, the object's in motion. It's either on its way up or it's on its way down. The acceleration is still negative 10 meters per second squared. Keep that in mind as we go through this. All right, first off, if I ask how long it takes for the object to reach its peak, that's going to be the first thing we look at. How long does it take for the object to reach that peak before it comes back down? Well, we know we have an initial velocity of 12 meters per second, and we just said the velocity at that point, or the final velocity, would be 0. We're just considering that part of the path of the object there. And we know acceleration due to gravity is at negative 10 meters per second squared. We're going to start with a familiar formula, v equals v sub o plus at. And we're looking ultimately for time. If we subtract our initial velocity over, then divide by acceleration, time is simply final minus initial velocity over acceleration. So in this case, time will be your final of 0 meters per second minus your initial of 12 meters per second divided by gravity, which is your negative 10 meters per second squared. So 0 minus 12 is negative 12, negative 12 divided by negative 10. First off, a negative divided by negative is a positive. 12 divided by 10 is 1.2 seconds. So in essence, it takes 1.2 seconds for the ball to reach the peak in its path. Now, secondly, if I'm asking how tall the building is, we're going to use a formula that's going to encompass the entire path of the object and its overall end displacement, just like the previous problem. So we have a vertical initial velocity, we have a vertical acceleration, and we have the time. So for our three different distance formulas, we're going to use the third one, the v sub ot plus 1/2 at squared. Again, we're using this one because we have a non-zero initial velocity and we have a vertical acceleration. So our initial velocity is 12 meters per second times our time of 6.5 seconds plus 1/2 or 0.5 times gravity, which is your negative 10 meters per second squared, times your time of 6.5 seconds squared. So now, whenever we type this in all as one line. I know last chapter I broke it down just to show you the basics with it. It's a lot easier just to type it all in one step on the graphic calculator. So you take 12 times 6.5 plus 2.5 times negative 10, and it has to be negative in the calculator because our initial velocity is positive because it's up, gravity is negative because it's down, times our 6.5 squared. And keep in mind, the only thing you're squaring is the time. Hit enter, and I get negative 133.25. And that will be in meters. And that takes into account the trip up, trip back to that original point, and all the way back down here. So again, if I draw an XY axis on my building, where the origin is here, I'm saying that the object lands 133.25 meters below where it started, hence the negative. If it was a positive, then the object's landing above where you released it. If it's negative, it's landing below. So those two questions, very similar to ones you have in your exercises and you'll see on your test, but it relates to throwing an object straight upward. The next two we're going to look at throwing it straight downward and outward.